Stress can affect our biological age, but the process can be reversed. Stress related to surgery, pregnancy or severe course of COVID-19 can affect a person's biological age. These types of events, the researchers found, are associated with accelerated cell aging. However, it turns out that this process can be reversed. Each person has a specific chronological age, which is counted from the date of birth. There is also biological age, which is determined by the aging of the body's functions. This age reflects the health of a person's cells and tissues, and can be affected by disease, lifestyle, environmental factors, and more. There have long been suggestions that biological age may be reversible. A new study led by researchers at Brigham and Women's Hospital is the first to provide strong evidence that this is indeed the case. Until now, it was believed that the biological age simply goes on and on. We hypothesized that it is actually much more flexible, says lead author Dr. Jesse Poganik of Brigham's Division of Genetics. New research shows that exposure to stressful stimuli speeds up the body clock. However, it turns out that the effect can be undone. Severe stress can cause an increase in biological age. But if this stress is short-lived, the signs of biological aging can be reversed, explains Poganik. The results of the analyses were published in the journal Cell Metabolism. A team of scientists has collected and analyzed data on situations that can cause severe physiological stress. The blood of elderly patients undergoing emergency surgery was tested. Samples were collected immediately before the procedure, a few days after it, and immediately before discharge from the hospital. The team also looked at blood samples from pregnant mice and pregnant women, comparing results from early to late pregnancy and postpartum. The third analysis looked at patients who contracted COVID-19 and were admitted to the intensive care unit. Researchers used DNA methylation levels to determine the health of cells and tissues in humans. The process of DNA methylation leads to changes in the activity of some genes without modifying the original DNA sequence. Its patterns change over the course of life and progress with a person's biological age, which may be greater or less than the age measured in years lived. Scientists can determine someone's biological age by measuring the chemical changes in our DNA that occur over time. The researchers noticed that the biological age increased in the event of stressful situations. However, in patients after hip fracture surgery, the negative effects disappeared after 4 to 7 days after surgery. A similar reaction was not observed among people who underwent operations other than those related to injuries. In studies of the effects of pregnancy on biological age, scientists observed a consistent pattern in humans and mice. Biological age increased during pregnancy until birth. These changes then subsided. The team also observed an increase in the biological age of patients hospitalized for COVID-19 after discharge from the hospital. The negative effects in women were partially reversible. However, the researchers did not observe significant changes among men. The authors emphasized that the biomarkers they use to determine biological age may be influenced by factors that have not yet been identified. They also note that not all individuals recovered at the same rate or to the same extent. Learning and understanding the various factors affecting biological age requires further research. Our findings challenge the notion that biological age can only increase. They also suggest that we can identify factors that will reduce it, says study co-author Dr. Vadim Gladyshev. Reducing stress can restore our biological age. This means that longevity can be increased by restoring health balance after stress, he explains. Swedish researchers have developed a wood transistor. Swedish scientists have developed the world's first transistor made of wood. Although it is unwieldy and slow, it works and has great development potential. This research paves the way for the further development of wood-based electronics. Wood, as we know, can be found in many everyday objects that surround us. In the rooms, the kitchen, the electronic devices. Is something not right here? Of course, the last item. But as it turns out, wood can also be used to build electronics. You can even make a transistor out of wood, as proved by Swedish scientists from Linköping University and KTH Royal Institute of Technology. The description and results of the research were published in the journal Proceedings of the National Academy of Sciences. Even with the most vivid imagination, it is difficult to imagine any electronic device without a transistor. In addition to controlling the current flow, it is able to amplify the signal, store data, and a group of them is even able to handle complex logical operations. Transistors were developed nearly a century ago and are considered by some to be as important an invention to mankind as the telephone or the light bulb. Today, they are a key element of modern electronic devices, and it is from their miniaturized versions that the processors in our computers or telephones are composed. And all this is possible thanks to the properties of semiconductors. And here is where the problem arises in the context of the potential use of wood in this capacity. It is by no means a semiconductor. Moreover, in general, making any electric charges able to move in it is extremely problematic. Theoretically, this problem could be solved very easily. All we have to do is turn the wood into charcoal. Then the loads would get not only a road, but even a highway, on which they could move without any problems. However, this solution could be unsatisfactory for many, because at this point it would no longer be wood. And here Swedish scientists enter the scene. Apparently nobody told them that wood is not suitable for constructing transistors. Swedish scientists decided to use balsa wood, scorp woolly. It is quite hard, but at the same time it is characterized by low density and a homogeneous structure. It was decided to remove the lignin from the wood, and a conductive polymer, poly,3,4-ethylene dioxythiopenum, polystyrene sulfonate, written as PEDOT, PSS, was introduced into the lignin channels. The very idea of U200B, U200B installing conductive material in wood in this way is not new. However, the scientists undertook to optimize the lignin removal process in order to create the most efficient channel for the polymer placed in it. Thus, it became possible to create a rather primitive transistor. In previous attempts, transistors made of wood were only able to regulate ion transport. And when the ions ran out, transistor stopped working. A transistor developed by Swedish researchers can operate continuously and effectively regulate the flow of electricity. It can also turn the power on and off, although with a considerable delay.